This is the IPv6 track, formerly known as BOF, but this is basically we are collecting a lot of content about IPv6 and just hopeful everybody in the room will be really interested in listening to. We have a bunch of people here that's going to be talking, and what is characterizing these people is that those are some of the people who stopped talking and actually started doing something about IPv6, and that's what we're going to talk about. So first we'll have John, who'll talk about broadband and cable, and David will talk about content providers himself, and we will have Tom about covering getting the content to the access to the users using the CDN. And we will have David talk about the enterprises and what happens in that area. And finally, Randy will come up and give us all a little talk about how we can all help getting this moving if we want to. And then we have put out some time for an open discussion that we hope that a lot of you will participate in. So, yes, that is the program for the next hour and a half. And please do ask questions, but also please prepare yourself from the discussion in the end. And we'll start with John.
Thanks, Dina. Thanks, Dina. Hello. So my name is John Brzozowski. I'm from Comcast, and I'd like to give you a bit of background here. So what I'd like to do is talk to you a bit about, to give you a little bit of background on some of the deployment aspects and considerations that we've had rolling V6 out into a cable network. I'm going to kind of quickly segue to what I think through some content that you've probably heard already, in various venues and whatnot, and kind of get to something that's a little bit more interesting and talk about some of the activities that Comcast is doing here at NADOC. So on this slide here, I'll kind of give you an overview of some of the topics that we're going to cover. I won't necessarily bore you walking through these. I will point out a few key pieces of terminology for those of you who are not cable aware. CM is generally meant to refer to a cable modem. You have MTAs, and that's what we use in the cable industry to deliver voice services to subscribers. We have set-top boxes, right? And I think most of us know what a set-top box is. And in this case, we're kind of making generic reference to set-top boxes. EMTAs and ESTBs are kind of being referred to in the context of where you have a single device that has a modem embedded with it. That's kind of collectively used to enable services in a cable broadband network. We have CPE, customer premise equipment, and for the purpose of this talk here, it's going to refer to anything that's kind of logically residing behind a cable modem. Which include things like, your Macs, your Vistas, your Windows machines, as well as IGDs, Internet Gateway devices. DOCSIS is the data over cable system interface specification. That kind of is the enabling technology for all of us here in the cable industry. Packet cable specifically is the technology we use for voice. And provisioning is the process by which we assign attributes and levels of service to subscribers, right? So it includes things like DHCP, TFTP, TOD. It's a collection of protocols. So for those of you who are kind of versed in DOCSIS and packet cable, this will have a pretty specific meaning to it. So some of the core concepts here that I'll kind of use to build on the rest of my presentation in particular. Initially, our drive to deploy and support or adopt IPv6 was largely so that we could manage a huge population of devices. We have a sizable network, and we have a lot of devices that are kind of sitting in the subscriber domain that represent a lot of IP addresses. In particular, we're talking about cable modems, set-top boxes, and even those devices that have modems embedded with them, like the MTAs. So essentially, over the past 4 years-ish, there have been a number of engineering work streams and efforts that we've kind of undertaken to get to a place where we can actually enable the management of these devices using IPv6. Some of the key elements, right, and this isn't a comprehensive list, right, because we'd be here for more than an hour and a half just on this alone, but some of the key components are the core network, the access network, and ultimately the provisioning platform, right? So the core network, I think we're all familiar with that, backbone types of technology. For the access network, for us, that's kind of the outermost edge of the network that cable modems terminate against, and then ultimately provisioning that's V6 enabled, which we use to essentially initialize. We require a provisioning system that is V6 enabled so that we can bring these devices online, convert them from one version of IP to another, right? So any one of these pieces are missing, and there's going to be a problem potentially with deploying V6 in at least in a cable environment. So the interesting point about this is there is a enormous amount of effort that goes into enabling V6 in all these different areas, and it's different types of activities depending on what you're looking at. So, for example, access network. There are potentially thousands of devices out there that require an update of some way, shape, or form. For provisioning, you're talking about hundreds of servers that require everything from operating system upgrades to application upgrades, data migrations. Very sizable effort, and certainly non-trivial. But after the day is done, you're talking about a huge amount of effort, and essentially where we're going to segue into the second half of this is we're going to talk about some considerations, but also how we can leverage the blood, sweat, and tears that went into enabling V6 on that infrastructure to talk about how that is an enabler for subscriber services over IPv6, right? And we'll focus on data services for now, essentially surfing the internet over IPv6. But incrementally speaking, the heavy lifting that we would do in those three categories really are kind of key enablers that we can kind of incrementally build on to add V6 to subscriber services. So, as I'm sure many of you already know, V6 is depending on who you're talking to and your vendor community, it's still considered new and certainly not mature in some cases, right? But frankly, that's kind of a byproduct of where we are as far as the internet community is concerned, right? We've spent the past 30 years kind of growing V4. We're not going to have 30 years to grow, to kind of take our time growing IPv6. So a lot of these things are going to happen, in my opinion, pretty quickly. What we've seen internally is the sheer massiveness and the number of devices and components that have to interoperate with one another. That has been a very a substantial effort, right? Because now you have implementers from different walks of life implementing V6 for the first time in many cases. And making sure that they all work with one another is critical. One poor implementation, it could actually adversely affect implementations that are, of a higher caliber or quality. So one of the things that we've seen is testing interoperability, particularly in a very diverse environment, is extremely important. And you know what? It's probably best to get used to the fact now that we're just going to find bugs and issues along the way. As recent as last year, we had a pretty substantial bug in some, in kind of a well-known operating system that actually had everything to do with V6, but we were not actually doing anything over IPv6 at the time. But it actually had the possibility to be very impactful for IPv4-related services and applications that we use to manage our network. And that's an important point to note. I'll kind of reiterate some notions around that in the last point here. And really, scale does make a difference. If you do anything in large scale, it just adds complexity to the entire process. I'm not saying it makes it impossible, but it's something that is a reality that everybody needs to be aware of. The bigger the environment, the more considerations and variables you have to take into account. And one of the things that we talk about internally is the work that we do in the V6 program cannot adversely affect subscriber services that are existing today, the bread and butter, right? So we have to adopt conservative ways that are low risk yet progressive enough to get V6 out into our subscribers' hands and ultimately into the network, so we can further our adoption of the protocol. And I'm sure many of you have a very similar mandate internally as far as your adoption is concerned. So all that to say, kind of as a backdrop to some of the things we want to talk about here moving forward. Even with connectivity available today, even if all of you had it today, the $64,000 question is what are you going to consume? What's your content going to be, right? What's it going to be like, IPv6.org or a handful of websites that us in the community that are aware of? That's just not enough, right? It's going to be the major content providers of the world that have to adopt IPv6 so that we get to a point where we start moving towards a point where we have parity between IPv4 and IPv6. So clearly having connectivity is just not enough, right? So we have to get to a point where we have, we kind of marry the availability of connectivity with the availability of content and services over IPv6. And ideally they should be aligned, right? I mean, one of the arguments that we hear, time and time again is, I'm not going to enable V6 on my site because there's nobody there to consume it, and then vice versa, right? I'm not going to enable consumers of it because there's nothing to consume over IPv6. I think we're kind of getting to a point where we need to look at how we change that way of thought, and I think what you'll see throughout the rest of this panel is some things that we've done as a community to really kind of create a tipping point and move past that I don't want to say stalemate of sorts, but it's essentially a logjam. So again, the goal here is to ensure that we've got a V6 capable infrastructure that we can use to deliver native IPv6 services. Now, this isn't not meant to imply that we're talking about IPv6 only services to subscribers. Initially, what we're talking about is essentially enabling dual stack connectivity to subscribers, which doesn't imply that there's going to be dual stack connectivity to cable modems or other types of devices that we can use in V6 only mode for management purposes. But clearly, what we would prefer to see is native IPv6 services extended to our subscriber population. And part of this kind of journey is us making sure that we understand and identify the issues and challenges associated with actually enabling subscriber services over V6, coupled with the enabling of content services. A perfect example that we hear about over and over again is you turn on Quad A records for your DNS servers, and suddenly somebody attempts to visit that particular site over V6, but they've got some kind of connectivity issues. You're going to have a disruption. You're going to have a potential impact to user experience, right? This points back to the point that we made earlier that we have to make sure that we take every step that we have available to us to not impact the bread and butter, the things that we're using to deliver services today. And I think there's a lot of learnings that we as a community are going to find over time. And ultimately, all of this kind of put together, the availability of consumers of IPv6 and available of content and services over IPv6. The goal here is to continue this, to kind of further this and use these activities kind of as a snowball or a domino effect, so that we continue to make V6 connectivity, content, and services more and more available over time. Right. The sooner we get to a place, and I know I'm stating the obvious for clear to everybody in the room, but the sooner we get to a place where we have parity between V4 and V6, the better off we're going to be as a community. The better off the internet that we know and love is going to be available, for the foreseeable future. So I'll talk a little bit about some of the things that we're looking at from a subscriber IPv6 point of view. And at the end of this, I'll kind of make mention of an opportunity for you to kind of observe this live. So for the bulk of this, the next few slides, we're going to talk about essentially two very basic models, right? So for those of you who are cable subscribers, you have two scenarios where you have either your Mac or your PC directly connected to a cable modem, or you have a home gateway that's sitting between you and the internet when you have a bunch of CPE connected to your home network. So in either case, there are a range of V6 prerequisites or requirements that are going to have to be in place in order for us to enable IPv6 to you as a subscriber. So part of this here is kind of an educational process, because we often get questions about, well, why do you require that? Why is that needed? It doesn't make any sense. I find that when I get those kind of questions and I spend a few minutes to talk to people about exactly why those requirements are the way they are, people get a bit more friendly about the whole topic and understanding what the nature of the requirements are. So the first model we talk about here is we have a subscriber CPE that's like your Vista machine, and I'll use that example very deliberately. It's plugged into your modem. Your modem will be, in this case, IPv6 only, but your CPE at that point will be dual stack. It'll be IPv4 and IPv6 enabled. And of course, in our environment, the expectation is that you'd have dual stack native IPv6 connectivity out to the internet. The second scenario here is you have basically a home gateway that is directly connected to your modem. It is dual stack capable, which includes the legacy behavior that you've come to know and possibly not love over the years, but it is what it is. On top of v6 capabilities like routing, firewall, different types of behaviors that you would expect inside the home gateway that's v6 enabled. And then of course you have your wide range of CPE that's connected to that home gateway that are essentially going to be either v6 enabled or not, and then ultimately access the internet. So for the scenario where we have a directly connected CPE like a Vista machine, in our case, one of the things that we expect to see is stateful IPv6 support in the DSP client. And I'll talk a little bit more about something that you can observe here in the hotel later, but that is essentially a byproduct of some of the technology that we use to enable v6 and broadband to subscribers. So that's essentially a DOCSIS requirement that we're trying to make people aware of, because today there's a very small population of modern day operating systems that properly support stateful DSPv6. Now, fortunately, the vast majority of the population, it's fair to assume, uses a home gateway in their home network, right? Some sort of a home router, Netgear, Linksys, D-Link, whatever. And we'll talk about that in a minute. But as far as the directly connected CPE is concerned, there's some basic fundamental requirements. We're not going to enumerate all of them here, right? But it's important to note, applications that support v6, a v6 stack, in this case, stateful DHCP-v6. So moving on to the home gateway side of things, the IGD, just a short list of the basics here, right? Stateful DHCP-v6 on the WAN interface, prefix delegation support, and of course some way internally for hosts to get their network configuration information, whether it's auto configuration or some form of stateful or stateless DHCP-v6, and probably one of the more hotly debated topics. I don't say hotly, but it's kind of out there, is, what's the security model? How are we going to, what does that home gateway need to do from an IPv6 point of view? Because we're kind of changing the game here a little bit, and we're basically opening everybody up to have global unicast connectivity across the IPv6 internet. And of course, all the CPE requirements that we talked about on the previous slide, apps, stack, et cetera, they all obviously apply, right? Without any of that, it's like, it's a bust. So Windows 98, 95, NT, all those operating systems, obviously not a lot of mileage. We're going to get there from a v6 point of view. So one of the things that is obviously a problem is today the vast majority of home gateways that are available today via kind of like retail channels have absolutely no support for IPv6. And the ones that do, they're kind of I guess probably the best way to put it is it's not necessarily uniform in nature. It's not something that we can kind of build an enablement strategy around. Some have different tunneling techniques and what have you. And of course, anything that is kind of remotely supporting IPv6, or even the things that are kind of becoming available now, simply the widespread availability of the same is just going to take time to happen, right? Even if we had a stockpile of them sitting here in this room today, by the time they found their way into the majority of our subscribers' homes, it's going to take time, right? Because there are some people who simply just don't want to upgrade their CPE. And then, of course, from a provider point of view, there are certainly some challenges that we have to overcome, which we believe are in the cards for us to kind of tackle. And that's essentially related to when we delegate prefixes to you as a subscriber, a residential subscriber. We have to make sure that we can get the routing information into the network so that we can, so that you can have a reliable v6 service to your home. And then there's a whole host of things that go along with that, like DNS. How's all that business going to be handled? And kind of reiterate something that we talked about earlier. Enabling consumers of v6 is just simply not enough, right? I mean, we could enable it today. If there's nothing to consume, you're all going to be sitting there at your house kind of tapping your fingers, say, wow, this is great. I wish there was something for you to do with it now. So, as I think you'll hear throughout the rest of this panel, that, we're trying to take efforts to kind of collaborate in the community to enable v6 from a content and services point of view. Up until now, it's been pretty sparse, right? And that's kind of a problem. And some of the other things that we're looking at internally are also kind of, portal and email enablement of IPv6, each coming with their own forms of challenges. I just left a working group last week called MOG. I don't know if anybody's familiar with it, but one of the things that became, that we've been talking about for probably 6 to 9 months now is how are we going to, for people who are sending email over IPv6, the whole listing, kind of methodology around, blacklisting and whitelisting people and using their IP space as a mechanism to determine whether they are good or bad. Very immature, right? Just kind of as an aside. Portals. A lot of portals out there are sitting behind, content distribution networks that are not yet supporting IPv6. That's a big deal, right? And ultimately, there's going to be a boatload of learnings that are going to kind of spin out of these activities that we're going to have to fold back into our plans and the things that we use to drive development requirements. So, at least from a Comcast point of view, a lot of what we do is to not only kind of focus on enabling V6 in our own infrastructure, driving the deployments of all the key components, that we talked about in the very beginning, but also collaborate with third parties to continue to encourage content services. Do it for ourselves as well. Document and share technical requirements and learnings with the community. In my mind, it doesn't do anybody any good for any of us to kind of keep kind of general information that's not proprietary to ourselves, right? The more we can share information about, our pains and sufferings as it relates to V6, the better off we're all going to be as a community. And I think that's an important point for all of us to consider as IPv6 adopters. So I'm finished, and I'd like to thank you all for your time. And I don't know anything else.
Hi, everyone. Again, Dave Temkin from Netflix. Just not. And I wanted to kind of elaborate a little bit on our lightning talk from earlier. That was to more or less kind of frame the challenges that we faced when looking into that, and the challenges that we face as we look forward to understand how we can actually make this work in an environment where we see a whole host and mix of environments such as native V6, dual stack, carrier grade NAT, the issues with V6 islands, things like that. So just a quick little slide about where Netflix came from. It started in 1997. They did an IPO until 2002, profitable in 2003. And you can see the progression here has been pretty fast. Between 2007 launching the streaming service and 2009, where we have nearly 10% of all U.S. households as our customers, not necessarily for streaming, but as a movie rental customer. Netflix has a history of setting trends within the entertainment industry. You guys have probably heard about the issues that we've had thus far with Blu-ray. Well, that's not new. When DVDs first came out, we had the same issues that required changes to the physical production of DVDs in order to make them more reliable, which we convinced the studios to do. Another interesting thing is HD DVD. We gave it up, and within days of us giving it up, that was pretty much the final nail in the coffin for the rest of the studios and device manufacturers. And one of the questions we ask is, can we help for IPv6 in the same sense? Most of our streaming today, or I should say pretty much all of our streaming today, is done via CDN. And most of the CDNs have a pretty sad story to share about IPv6, from anywhere to we have no plans to we don't feel it's a viable business model to we think that there's going to be some other technology that comes out and V6 is not the future, and for now we'll be okay with carrier grade NAT or whatever comes down the pipe, and that's, in our minds, not acceptable. As everyone saw earlier who was here for the lightning talk, our website and streaming control services are all IPv6 enabled. We're able to roll this out in less than a month's time. This means that you can visit our site from a native IPv6 connection end to end and experience all the services that we have to offer. We realize that no one is going to need a native service anytime soon. However, we wanted to set the example, or at least the framework, for others to be able to deliver the same type of content. We didn't want to, quote unquote, cheat. And for the kind of traffic that we're doing, you know, we have millions of customers streaming today, and they're using hundreds of gigabits at any point in time of traffic from that streaming service from our various CDNs that we do business with. That's a lot of traffic. That's a lot of traffic that, you know, Comcast doesn't want to see having to go through carrier-grade NAT, and it's traffic we don't want to have to see going through carrier-grade NAT. So we would rather it end up on V6, and we'd rather be ahead of the trend than scratching our heads 2 years from now going, why didn't we see this coming? Because we clearly see it coming. Today we have nearly 15 million Netflix-ready devices deployed in the United States. That's not necessarily 15 million in use, but that's 15 million devices that could stream our service. In a 3-month period, over 1.5 billion minutes watched, and that's about that statistic is, I believe, about 6 months old, so that's actually gone up since then. The biggest problem we have, going back to the demonstration from earlier, we were able to get Silverlight, which is our PC, Mac, Linux client, IPv6 enabled very quickly, and it works, and we've no issues with it, at least that we've seen thus far. Getting these devices to be IPv6 capable is a whole other nut to crack. Not only do we have to deal with people like Microsoft for the Xbox and manufacturers like Roku for the Roku box, but we also have Blu-ray player manufacturers like LG and Samsung who don't have representatives here in the U.S., whom we then would have to set a framework for them to develop against. And it's going to be a challenge. We realize that. In our case, again, because we were only doing it for the PC and Mac clients, we were able to roll out IPv6 very quickly. You know, the corporate network, as I covered earlier, was very easy. There was not a lot to it. You know, we're pretty much up and running. Most of our corporate desktops have access to V6 at this point. Production network was really not that much harder. You know, the support for it has been here for years. This is not anything new. Cisco has known this has been coming. You know, everyone has known this has been coming. And our developers were actually very interested in it when we brought it up. But we ran into the classic, we have other very pressing business priorities that are not a problem 18 to 24 months from now, but are a problem right now. So how do we weigh the development effort that it's going to take to get it running now over that? And developers were willing to put in their own time, come in early, leave late, to get this out and get it up and running. This diagram that I showed earlier showing how we actually did, again, from a very basic perspective, launch the website. Obviously, there was code changes required on the website. There was code changes required within our player. But at the actual network layer, it was very, very simple. The challenge in putting it all together is basically we need the ability to support a V6 client, a V6 VIP, and a V4 real server. And you know, load balancer vendors have really come to the table and realized that this is the future. And a lot of this is driven by growth in Asia. A10 Networks is a great story about how they won business away from another large load balancer company that many of them are formerly affiliated with, based purely on their IPv6 support within Asia. As I mentioned, you know, Citrix and F5 both have the same support, and you know, we chose Citrix, but you know, certainly could look at other platforms. There's a real lack of insight today, though, as we discussed earlier, and I brought up with Patrick. There is no real GeoIP services today. There's one company that's starting to look at it, but products such as Akamai Edgescape have no V6 visibility. MaxMind doesn't have any V6 product yet. And it's really a problem for a company like us who deal with regional-based licensing. where we have the license to stream a movie within the United States, but not necessarily in Canada or in Europe. So that is a big challenge for us, and we really need that insight. And for now, we can build those restrictions based off of registrars and things like that, but as we all know, that's not perfectly accurate, not even close. Dual stack load balancing, again, very helpful in that you can use the same gear that you have today on the back end and simply just touch your front end with new gear. If your application already supports full inline load balancing, which is your classic source NAT, layer 7 type load balance, layer 4, layer 7 type load balancer, you can do this today with no real issue. If you support full layer 7 load balancing, you can even do all sorts of rewriting tricks that could potentially mean that you don't even have to touch your application. And this is across multiple protocols, not just HTTP. We'll skip over that because we went over this earlier, but this is basic configuration for a NetScaler is really not complicated. And this is a little bit more complicated configuration for a NetScaler if you needed to replace, say, references coming back from your web server. If your web server was returning an absolute URL that was www.netflix.com and it needed to return it as IPv6.netflix.com and you didn't want to make a code change, you could do that in your load balancer. Again, 3 lines of code, not very complicated. But one of the biggest points here, and the reason why I call this out, is if we solve the quad A problem before A problem, you won't need this stuff. And, different people have different solutions to it, and it's kind of fixed in some stacks, but not in other stacks. But if you have an XP Service Pack 2 box that is V6 enabled, you're kind of screwed. And we don't really want to deal with having users that have a negative experience because they have a V6 island network that doesn't have connectivity, but their stack thinks that they do. So what we really need is we need better CDN adoption, as I mentioned before. The stories that we've gotten back from many of the CDNs are just not acceptable. We're glad that Limelight came to the table, and there's a couple others out there who have a story, but for the most part, the big ones don't. We really don't want to deal with carrier-grade NAT. We don't want to deal with complexities. We don't want to deal with the implications on our traffic. We don't want to deal with the further loss of control of our traffic. And we don't want the lack of visibility that's further introduced by carrier-grade NAT. And we see that as a positive driver towards V6 adoption, whereas a lot of people may end up just dealing with carrier-grade NAT. For our traffic profile, we don't think that that's really acceptable. Why can't I just turn on V6 for www.netflix.com? There's too many island IPv6 networks that have no end-to-end V6 connectivity, but the resolver thinks that they do. Vista, for how much people complain about it, at least got one thing right. It doesn't ask for quad A's unless you have a global V6 address, which is fine. However, if we start seeing V6 NAT show up, which is a distinct possibility at some point, that's going to become a problem again. It doesn't help most of the world, and we can't chance having that timeout for the resolution before browser fails over to the regular A record. Our business, we've seen streaming increasing for the first time this past quarter to offset DVD shipments. We're seeing significant uptake on the streaming usage. New device support coming, new content coming, drive for higher video quality, as someone alluded to earlier about HD encodes. This all equals more bandwidth used, which means more infrastructure, which means more customers, which means more addresses used, just further contributing to the problem. So that's it from my side.
Hi, I'm Tom Coffeen with Limelight Networks. I'm going to be repeating a lot of the same themes that you've heard from the last two presenters, and hopefully in different sentences, so you're not completely bored. First thing I want to talk about has been mentioned a couple times already. Some of the things that drove Limelight toward the direction of adopting v6 and being in a position to take advantage of the opportunity to do a compelling beta with Comcast and with Netflix. So the first item I have up there is a little sort of ambiguous. Content providers and subscriber networks desired network transparency for content delivery. And reading that sentence again, I think what I'm really trying to get at there is that, you know, we're all after kind of the same thing as far as delivering services. Limelight's role as a CDN and in part as a transit provider means that it's in a position to really try to keep that network layer transparent so that there's no downward pressure on innovation due to things like V4 depletion, V4 depletion adaptive procedures like carrier-grade NAT, which has been mentioned a couple of times now. So we look at something like carrier-grade NAT, and we're as scared as anybody in the possibility that a lot of the tools and the products that we've developed and come to rely on over the years have an unknown future in a scenario where the end-to-end connectivity is broken. A couple of examples. Something that Dave mentioned about geo licensing, basically being able to determine the endpoint of an IP address. I mean, that's obviously very critical for content providers that have licensing agreements that might boil down to a single incorporated area. And if you have no ability to know, if you have a bunch of subscribers that are behind a carrier-grade NAT box and they're all appearing from one IP address, obviously it's going to break that revenue model for you. So the second thing, I mean, we realize we've all seen enough graphs coming to Nanog that show V4 depletion. And we know that that's right around the corner. I think, though, that a sort of nuance that I'm hearing a lot of since I've been listening to these guys and being evangelized and becoming evangelist myself for V6 is that, you know, we know that V4 isn't going to go away. And we know that V6 is one of the ways in which we're going to try to adopt to make sure that we maintain an innovative posture for the products that service providers are going to develop and support. So, you know, as much as I'd like to say, you know, hey, we're going to beat the clock and we're going to get V6 totally deployed, and you know, I wish that would be the case, like the end-to-end internet that we've all idolized from the beginning or idealized from the beginning. You know, that's right around the corner. But my thought is that it's really, you know, about trying to make sure that we have the most amount of flexibility for developing products going forward, and V6 is a part of that. It's a piece of that. But at least part of the message that I'm hearing from these guys and part of the message that I want to deliver is that, you know, it's not as scary as I assumed it would be. There's a lot of things that work today. There's a lot of things that can be deployed immediately. And then you can get into the really interesting problems. But the actual basic deployment is while not trivial, it's quite manageable. So you'll have to indulge my use of a marketing graphic here. Limelight is kind of unique in the sense that it has connectivity between its POPs. So from a traditional CDN model, that's optional. You don't necessarily need it. In our case, we do, which added both a challenge and an opportunity for us in that we had to turn up V6 on the core network before we enabled it at the edge. The opportunity was that, as most of you have heard before or maybe realize yourselves, is that you can actually turn up V6 in a dual stack environment relatively easily. And I say relatively, I mean, there's obviously challenges that come along with that, and we certainly ran into our share. Part of it is that, well, let me just finish up with this slide. Our V6 deployment obviously has to touch both the core and edge networks as far as we're concerned, domains that we have control over in both cases. So the core deployment challenges that we really had to deal with, obviously, and you've heard this before from our other panelists, keeping the V4 production network stable is critical for obvious reasons. You know, the biggest part of that is obviously revenue and keeping customers happy. Another smaller, maybe more subtle part of it is that if you are trying to evangelize in your organization for V6 and get people to see the light, the last thing you want to do is break the V4 network in your process of rolling it out. The IGP selection for us was not trivial. We're currently running ISIS in a v4 environment. Initially, there was maybe the thought that we could overlay a different IGP in order to basically completely sequester off the v6 portion so there'd be absolutely no interference with the v4 network based on things like SPF calculation, if not resources available on the platform. Down the road, it was decided after a moderately sized test network of OSPF version 3 was rolled out that ISIS would probably be better to only have one SPF to have calculated on the router, to have only one IGP to administer in the core. For administrative reasons, operational reasons, we're very comfortable with ISIS in our environment. So making the jump back over to ISIS in the v6 space was manageable. We didn't run into any untoward turbulence doing that. There were one or two occasions where we had issues that were not so much vendor related in terms of the platform failing, but issues that had to do with the intelligence that the vendor was able to offer in the process of rolling out the steps for rolling out that particular implementation of v6 ISIS. So in other words, because there isn't a huge volume of information of other customers and other folks that have done it and recognized where the pain points are in getting the administration up and working, we were able to discover those on our own and report them to the vendor, who was then able to go back and type up some sort of as-built for how to do things after we'd already experienced the turbulence. So that's something that, depending on your vendor, you may have better or worse luck with that. So I have vendor support or platform instability, and I guess I was just going to say choose one. You can't have both in this case. Transit and peering, as a content provider, obviously content provider network, content delivery network, excuse me, we obviously benefit from having as many egress points as possible. So we had to figure out how we were going to get the peering piece happening as quickly as possible to make the CDN piece as relevant as possible based on delivering traffic to its closest point of request. Transit, there aren't that many options out there. I mean, as I'm sure you realize, we were able to leverage our relationship with GX to get v6 transit up pretty quickly, and Martin with Hurricane Electric was very helpful in getting us up and rolling on v6 connected to his network. We were able to get our exchange points up relatively quickly. In many cases, the v6 addresses or the v6 subnets are published. They're common information. If you know the peer that you're trying to connect to on the other side, there isn't even any intervention required by the IX. It's just a matter of getting the session up. So that piece, the only caveat I can say for that was that getting down to the wire where we really wanted to make sure the demo was going to work successfully and be able to stream the content over v6, I noticed some strange behavior on the transit network. Comcast is available directly through GX, and if you want to get to them through Hurricane, you have to go through GX as well, so I figured I would just have them come through GX and skip the middleman, make the transaction times as low as possible. Well, I noticed that all my traffic was being transited through Amsterdam. Traffic being requested from, content being requested here in New York was transiting through Amsterdam. And I was announcing consistently, so I'm not really sure, what was going on. I didn't really have the luxury or the time of dealing with the international transit provider behemoth operational support to try to get to the bottom of things, because it was literally down to the wire. So I had to do some creative routing to actually, just do some inconsistent announcement to get the traffic to transit where I needed it to transit to cut down on the transaction time. So it's just a little bump in the road. I mean, those are the types of things that you're going to end up running into. And, going forward, obviously, we're going to develop some operational capabilities that allow us to deal with v6 problems in the same, if relatively efficient way that we deal with v4 problems. The final bullet point here is just trying to reflect some of the anxiety that I've personally felt dealing with such a large address space and not really having any tools out there that help me keep track of what's what and not wanting to use a spreadsheet. There's actually some products out there that are commercial products that I know some folks are using. BT has their IP control product, which is supposed to work relatively well. Whois it's actually ported for v6, but the documentation is all 10 years old. And the gentleman at our organization who I was told was responsible for maintaining it and administering it, I contacted him and I said, hey, I'd like to get v6 working in Whois so we can start tracking some of these addresses. And he informed me via email that that he didn't do that, that he didn't set up RWhois and he didn't administer it. And then about 3 weeks later, I got an email from him that went to the whole group that said it was basically instructions on how to add v4 subnets to RWhois. So it's kind of interesting. He doesn't administer it, or he didn't set it up, but he was telling me how I could add the v4 subnets. So you may run into that in your own organization. You know, folks that aren't ready to get on board with whatever the v6 challenges of the moment. In that case, it was RWhois. I found an application called HACI. I'm not sure how that's pronounced. It's very rudimentary. It's PHP-based, MySQL. Uses a tree-like structure, and it's kind of hard to see up there. But if you go to the website, it's actually available through SourceForge. I've traded some emails with the developer, and he's pretty responsive to issues that I've run into with it. So it's better than a spreadsheet, I'm guessing, at this point. So the Edge CDN deployment, I can only speak about this very generally. My sandbox tends to be the core. Part of the reason that I can only speak generally about it is because it happened so quickly. As Dave mentioned, it's really been the last 3 weeks. The core piece has been done for us, for Limelight, for a few months. Getting the Edge piece up and running is really relied on a gentleman in our organization named Colin Rouser, who went the extra mile to make things happen. And that's really kind of part of what it takes. You have to have people that are going to be engaged and be interested in doing more than what their daily operational tasks are and daily architecture tasks are to jump in and get their hands dirty with the challenges. And Colin was excellent in doing that. Unfortunately, I haven't really had a chance to really look under the hood and see everything that's been done. So speaking about the architecture, I can really only do it in sort of a general fashion. The first thing is not surprising. I guess I back up and say if you wanted to think about how you would build a CDN that supported v6, and you were curious if you could use existing tools, open source tools, and a collection of tools and appliances that you might expect to see in any CDN, I think I'm here to say that I can't articulate exactly how we did it, but the answer is absolutely yes, and it's absolutely it may not be trivial, but it's manageable. Very first thing, obviously, server support. I don't think we could ever really determine when we compiled v6 support out of the kernel. It happened quite a long time ago. And when it came time to compile it back in, it was something, obviously, that had to be one of the first steps in getting things going. And not a trivial step in the sense that if you're going to touch every server or some significant subset of servers and upgrade the kernel, in a CDN environment, you're used to doing a lot of touching of machines and updating and upgrading, et cetera. But certainly a lot of extra effort there. Integration with core, that's really just about what that works today, what applications that you're using, what things at the edge, what open source applications that you're using that have v6 support ostensibly, that you may find out the v6 implementation is either partially working or not working the way that you need it to work. But it's something that we were able to dig into and get solved pretty quickly. DNS architecture is extremely critical. Dave was talking about the problem of v6 islands and having v4 DNS servers serving quad A addresses for which they basically have no v6 connectivity to, which can obviously break a lot of things. We were just as paranoid about our v4 DNS architecture as we were about our v4 core architecture for obvious reasons. So we built an extra layer of DNS resolution to handle v6 initially, did everything as dual stack as possible and as responsive to both v4 and v6 as possible, while maintaining a certain isolation from the existing v4 production DNS network. Down the road, obviously, for reasons of performance, we'll probably want to pull that back and figure out how to have one set of authoritative name servers that's handling both v4 and v6 for reasons of performance. So yeah, that's really the intermediate DNS architecture, pros and cons of that. Here's a very generic diagram. There isn't anything in here that's really shocking from the standpoint of what you would expect to see. In fact, you could probably just take IPv6 off the slide and see a nice CDN DNS transaction taking place, what you would expect to see for the generic CDN. But again, the message is that it works. It's there and it works. It's just a matter of getting it configured for your particular environment. So the tasks that we have remaining for ourselves, OSS support, as with a lot of companies here, I'm sure there's certain things that you're able to do with turnkey applications, certain things that are just built completely from scratch, and then everything in between where you're not really sure what kind of effort it will take to get your applications up to speed to handle a new technology or new protocol. And that's definitely the boat that we're in. We need to make sure that whatever we're serving, we can bill for and support. Operations and administrative integration of new protocol. And this falls back into the domain of the role of the evangelist. So, there's going to have to be one or two people in the organization that are willing to help people overcome what may simply be fear of the unknown, fear of what they expect to be extremely complex and unmanageable. And just like every other protocol that we ever learn to use in the networking world, when you start digging into it, you realize that it is manageable and it is learnable. So just getting operations administrative people up to speed in that regard, and making sure that that we sort of get to the bottom of reasons that we might be getting pushback from other areas of the organization. It's one thing to say, we don't really know how this works and we'd like to have a better idea of what's coming. It's another thing to say, well, we're not really going to do this yet because we don't see any need for it. The sunlight is a great antiseptic in that regard, in the sense that, if you provide the knowledge that people need to feel comfortable with the technology, then, theoretically at least, there's a greater opportunity or chance that they'll be willing to do what they need to do within their particular silo to help the V6 rollout in their organization. Test under load, that's a big one. Obviously, there's not a whole lot of V6 traffic out there, production traffic. Once we ramp things up, where are we going to run into pain points? How well will things scale, et cetera? We don't really know the answer to those questions yet, but that's obviously part of the fun. And then full support in IPv6 of existing IPv4 products. And that's really sort of forward-looking. Whatever we start to develop from scratch to provide our customers with, the next level of CDN service, going forward, we have to really look at the ways in which either V6 will support it or won't support it, or carrier-grade NAT may break that particular product once CGN goes in a major way. And I believe that's it. Thank you very much.
Thanks very much, Tom. Hi, it's Andy from the Internet Exchange in London called LONAP, and an ISP consultancy called NetSumo. Okay. I'm going to talk about IPv6 when it's used in the enterprise sector of our industry. And I'm going to loosely relate these, well, hopefully tightly relate these items to this agenda. Going to look at why enterprises are rolling out V6 and how they're doing it and what they're seeing when they do. In addition to my own V6 rollouts across our own network, which isn't really a service provider network, and occasions when we've rolled V6 out to other non-service provider networks, I had a few phone calls with these three individuals as well to see if what I thought I knew was what they knew as well when they'd rolled out, when they rolled out V6. So hopefully got quite a rounded view of different sections of the industry to prove that what I believe the enterprise sector is seeing is accurate. What were the business drivers? Well, everyone seems to identify the same particular reasons to roll out V6. It's not just V4's exhausting, but in the enterprise sector, loads of things that didn't used to need IP and consume IP addresses are now doing so. So there's an enormous demand for addresses, for example, with control devices that may be used to talk to a bit of machinery via serial. Well, now they're talking over IP. So there's a huge demand for addresses, unprecedented. And for these organizations, running out of addresses would be a real concern. It's business affecting. Additionally, organizations maybe involved with e-commerce want to make sure that they can deal with every section of the planet, or as much as possible, as many hosts as possible on the internet, so that they can maximize their audience or guarantee reach as best as they can. And additionally, when they try and partner for maybe tenders with government departments, they're expected to have V6 on their infrastructure because governments have written that into their own procurement policies. So enterprises is starting to get really geared up to roll out V6. Everyone who's rolled it out so far has identified two key reasons that they've started early. A gradual change is much cheaper, much easier to orchestrate than a big bang rollout. Additionally, it lowers your risk. You can learn at a more steady pace. You don't have to make it the top priority, and therefore that leads to continuity in your organisation. If you're in the audience and you represent an enterprise now, these are the key items that you need to put on the document you make on your business case when you get home. What was the process for rolling out V6? Well, the sensible organisations, way before they actually started configuring kits, changed their procurement specification to mandate V6 support on any equipment that they bought. So if they were buying software, if they were buying new infrastructure, they made sure that they were going to be able to configure V6 addresses on it. By and large, the organisations I spoke to used their existing change control process to introduce V6. That means that it's not scary for the people who are rolling out other tech projects. It looks like a normal piece of work, and that was very important inside large organisations. Small organisations are different. You can have a couple of V6 advocates who wake up in the middle of the night and do a V6 blitzkrieg configuration on your infrastructure. But big organisations with a lot of kit need to roll this out gradually with their existing change control. It really, really has to be a normal project that doesn't look and feel different to everything else. What were the very, very first observations? I'll go into some more detail, but as an executive summary, basically the routing infrastructure was broadly well supported. Everything that basically the service providers have worked on and given feedback to is well supported, and things that are more used in the enterprise sector seemed to be less mature, and I'll explain that and go into more detail now. Here's a typical generic nameless enterprise network that I've diagrammed. It's got some services that are run out of a data center. It's got some branch offices and a headquarters where lots and lots of people work and lots of equipment that consumes IP addresses is based. Where is V6 working and not? Well, user operating systems that are being rolled out today tend to have actually quite good V6 support. It's sort of working. When you roll it out, users don't notice, and actually that's correct. Users don't know they've got a V4 address, they just know they can get to the services they need. Some internal applications, if you've written your own protocol and your own applications to solve a business process somewhere, then that's possibly not V6 aware yet, but that's an organisational challenge to solve with your change control, etc., etc. So the operating system structures seem to actually have generally good V6 support. Again, server operating systems also appear to work, so provide a good basis for any services that you actually host. If you run open source platforms, they tend to be the most mature for V6. Linux had rudimentary V6 support before it was even called V6. It had IPNG support, and it's been a really good test bed for V6, and now a really good production bed for IPv6. Also, good support on, I'm going to say routing, I know you prefer routing here, core routing infrastructure, the stuff that basically service providers also use and have also given feedback on, that's working really, really well. Support varies when they try and buy internet services from you guys in the room. In some geographies there is really good V6 adoption maturity already. In some geographies there's no V6, so a major international organisation is struggling, but enterprises are going to start to put pressure on the people in these rooms to consistently support V6, so be aware and be ready if you're not doing it. The enterprises are really frustrated by CPE, so if they have home workers or branch workers or just have fairly typical CPE inside their organisations anywhere, it can be quite hard to buy CPE that does it. I know when I bought my CPE at home, I mandated V6 support. I followed the procurement process that I advocate, and I bought an 1801, and that doesn't pass V6 frames across the BVI interfaces, the bridge between Wi-Fi and wired. So there's still gotchas, but they are bugs that you can put pressure on the infrastructure vendors and make sure that they're aware they're aware that we see it as a priority. There's glimmers of hope in various bits of kit. Apple's CPE, I'm told, does it very well. The Fritzbox in Germany does it very well. There's some other manufacturers of CPE that are working on V6 support, so there's glimmers of hope. We just have to clone that and copy that across the whole of the industry, really. People are telling me, even though there are firewalls that do V6 security, people are telling me that it really feels like a bit of an afterthought. It's really, really possible to do, but on some kit that might be older, forwarding performance is less good because it's software forwarding rather than hardware forwarding. Also, V6 configuration appears in the web interface, not the CLI from time to time, or the other way around, which is really frustrating for people who want to build a common support harness for their organisation. Additionally, there can be quite an inconsistent feature set. So maybe some products in the range do Protocol 41, others don't. But there are plenty of firewalls that do V6 and are used by enterprises now, so it's not an excuse not to roll out V6. Just need to procure better kit. Ironically, the devices that are pushing out, or that are consuming the most addresses, these controller devices inside organisations, they have really, really cheap Ethernet chips inside them that don't maybe support V6. Or basically, if you're working on building these control devices that used to work over serial and now work over IP, you really need to make sure that they can work with V6, because these are consuming tons of addresses inside organisations. Additionally, people are talking about RFID Ethernet, which I hadn't come across until I started this process. That's going to be really interesting, because imagine if every RFID chip has an IP address. We better hope it's IPv6. VPN gateways, a lot of people are telling me that the VPN stuff that they've got has poor V6 support or no V6 support. So maybe they're rolling out V6 services, but their home workers and teleworkers can't use them. But that's something that enterprises are putting pressure on the vendors to support. Also, load balancers. Traditionally, up to maybe this year, it's been difficult to procure a load balancer that has supported V6 really well, but as you've heard from the other guys on the panel, there are vendors like A10, Citrix, and people who've just made it work with Apache and Mod Proxy Balancer who could have got really good load balancing support working. To sum up the key grumbles, infrastructure doesn't have a consistent CLI necessarily between V4 and V6 command sets. Please be really if you're a vendor in the room, please take this as a message to be consistent and audit what you've already got. Also, people are complaining to me about first-hop redundancy protocols because they don't behave in the same way as IPv4. So people who have big hosting infrastructures are finding that getting people to understand how to set first-hop redundancy isn't working. People don't seem to want to use the link local addresses as the first hop because it's not clear to them that makes sense. Additionally, while I'm complaining about things that seem to be stuck without being fixed inside certain IETF processes, people are telling me that DHCP v6 with no ability to set default routes is a big blocker for them because they don't want to use router discovery, router solicitation. So people told me they had some interesting bugs that they only found out after production. So turning on various features, various encapsulation, on some hardware seemed to cause all v6 to be forwarded via the CPU rather than any of the hardware. Everyone tells me that when they found a really nasty showstopper, the vendors have been careful at making that problem go away. They just wish they'd found it in the lab sometimes. Also measuring the success of the v6 rollout, how much v6 traffic am I doing compared with v4 sometimes is a bit of a problem. Transitional technologies, everybody seems to want to avoid transitional technologies, and I think it's a really sensible thing for enterprise to do because they are perceived to have poor service levels rather empirically. Device support for transitional technologies sometimes isn't good, whereas it is good for native, so you might as well roll straight out onto native. And if you have to do a rollout onto a tunnel and then another rollout onto native, you're doing twice as much work as you really want to, when the alternative you can go and party at Nanog instead. The successes, general successes, users aren't noticing the difference, and that's correct. And also people are telling me that training their help desk isn't complex. Something else I found out was that Microsoft have got a very, very interesting product coming out inside the Windows 7 family, Microsoft Direct Access, which is an ad hoc VPN that creates IPsec guaranteed tunnels over IPv6. Now this is nice. It's a good idea to mandate this over v6, I think, because it's just an extension of the end-to-end argument. If we're going to run out of addresses, we're going to see lots and lots of layers of NAT in the v4 world. VPNs don't really work very well unless they have end-to-end connectivity. So it's a very sensible mandate. Also, nobody seemed to mention that they wanted NAT, and I thought that was really quite good, although as v4 depletes, we will see NAT in the v4 world. Enterprises are really telling me if we can keep NAT out of v6, that will be good for their tech teams, and I really have to agree with them. I've gone quite quickly because I'm hoping we've got time at the end for a conversation that falls out of this, but here's my details if you want to send me an email or hate mail, and I'm going to hand over to Randy. Who's he gone? Thanks.
Are you coming? It's up here, yeah.
Just diving for this in case. Randy Bush, I'm not from IIJ today because you might have an H1N1 virus. And so therefore, IIJ employees are not allowed to travel to the United States. So today I'm not an IIJ employee. How many people here think doing a non-trivial V4 network is the kind of thing you do without much experience or education? Exactly. Well, V6 is not that much different. So I'm going to say some things that other people have about some of the difficulties of being there, but that's the point of the story, is you're going to be doing it. So what do you need to know? Excuse me, dual slides. I'm going to point to this one. What I want, I don't have a lavalier, do I? What I want is a V6 network that has feature parity with V4. I want the software that I run to. I want the routers. I want the switches. I want the customer premises equipment. I'm just trying to build another network, you know? I want performance parity. I want the transition and compatibility tools. That one lies at the IETF. And I want price parity at no extra license fees. Thank you, Juniper. Yes, V6 sucks. An IPv4 natted world sucks much worse. Much worse. Get over it. You're going to learn to love IPv6. Or you're going to really pay through the nose. What sucks about V6? Well, routers do not yet have performance and feature parity. Security products and load balancers are just catching up. Netscaler finally does it. Okay, and that's what the big boys and girls use. IETF is late on the transition tools, but they're catching up. And there are implementations that are usable. I still can't go to CompuCrud at the corner and buy $50 replacement CPE like I can for V4. You know, Linksys doesn't do it yet. The IPv6 backbone is chaotic. It has tunnels, MTU problems, and is sketchy. At the IETF in San Francisco, when we turned up the connection, our V6 using NTT, it went through Hong Kong to get to Google because NTT and Google are very poorly connected because they're playing ego games. What's going to fix these? When there's money on the table. When people who wear funny clothes come and say, fix that peering problem, fix that router code, who go to John Chambers and say, make it so the TRS-1 moves packets like a bat out of hell, whether they're 6 or 4, etc. When people's money rely on it, all these problems will get fixed. The problem is there's a mild chicken and egg problem. But it's worse because there's a stone wall coming in 2 years. The user doesn't give a damn. They just want their packets. They don't care what they are. They want to run YouTube and MTV or whatever it is. It's our problem. We have to continue to deliver services. The user doesn't care about packets. They care about services through V4 free pool runout. So we have a choice. Okay? What's going to, darn, I got to stay here. What's going to make the dollars? Your RFPs, pushing at the IETF to clean up NatPT or whatever it's being called to save face, and A+P DS Lite, to get around carrier grade problems. As we say, CGN is just not the solution. We need to shake out the software, the platforms, and IPv6 traffic. Okay? That's going to push the dollars. You have a choice. There's a brick wall out there about 2 years. You can do this, or you can do that. Okay? Why do you want to get moving now? Why do you want to get moving 2 years ago? So you will have experience. You couldn't build a V4 network without experience and education. Well, you're not going to build a V6 one either. You want to get your equipment on the upgrade path and your vendors of any special gear you use on the upgrade path. And if you want to know what happens when you don't do it well and do it well enough in advance, go to Wednesday's last session about NAT. And if you think your customers are going to like that, you're in trouble. Okay? When you're selling NATs, 5 layers of NAT, and your competitor is selling clear through, you're going to be hurting. You get experience now, and your software will be on the upgrades path. Your knowledge will be on the upgrade path. You're going to know the trade-offs and costs. You don't have to convert your world today. Convert your head. Get capable. As I think someone said earlier, or promised to, one clueful person in an organization can make a whole lot of difference to that organization's capability as they start to have to do this. Okay? You can make intelligence decisions, and you can give management real data and options. If you understand today what it's going to take in technology to move your network forward a year from now, you can start the 2 little pieces that are going to be the worst quietly in a skunk works if you have to, so that when you get a year out, they're not showstoppers. You need to know if you're going to have showstoppers and get them out of the way today. So pick a little part of your network. Pick the external or the internal. I think the external, and I'll tell you why in a second. Chris Morrow, for whom I have an immense amount of respect, who's still up in security, says pick an internal one so it's not customer facing. I'm going to say pick the external. For instance, just put makeup on your face. Move your SMTP servers, your DNS, and your HTTP to dual stack. Okay? And it's easy. You can do it with a very small amount of resources. Chris says pick an internal piece so you can experiment without effect. I like external because it's going to drive V6 traffic, which goes back to the financial pressure, which goes back to straightening out the network before we hit the brick wall. So I did it. What did I learn? I learned how to configure my equipment to actually push the packets. When I went to do my SMTP, I learned that DNS blacklists don't support V6. So I had to take my SMTP server and say, is this a V6 address? Branch around it. I learned that the IPv6 reverse tree is very poorly populated, so don't do a DNS check reverse for services. I learned that my Jabber server supported V6 well, but it couldn't be on the same port as V4. Disgusting. I could convert SMTP, HTTP, and DNS in a day or 2. Okay? But don't put the Quad A record in until all the services there are V6 capable. Otherwise, somebody's going to come chasing down that Quad A and get hurt. And that's your customer, and we don't normally like to hurt customers. What's the present value of reducing your future cost 2 years from now by 50%? That's the question. Okay? If you start now, you reduce your future costs, you have future agility, you can make decisions, you can allow your senior management to make decisions, et cetera, et cetera. Okay? So you can pay less and slowly now, or you can pay a lot more and steeply later. You have a choice. I hope you take the latter choice because I'm your competitor, of course. And that's it. Bripe is also doing this kind of thing, and they actually interviewed a whole bunch of us, and you can see the movie instead of reading the book. It's on YouTube. Thanks.
Thank you, Randy.
So, folks, there's something I wanted to mention to you quickly. I may mention during the front end of the panel that we had that we'll talk about something here of interest to kind of brings all this together. So we were able to, as Comcast, organize a broadband cable demonstration here in the hotel. Anybody who's kind of checking out the nanog46.comcast.net site, we put some information out there. Certainly would encourage you and invite you to kind of reach out to me and kind of set aside some time to take a look at it. It's not a massive room up on 33, but certainly can accommodate a bunch of people. We'd love to show you what it looks like. So just wanted to kind of throw that out there and make sure you all were aware that it was here and functional. So please reach out.
Thank you. So does anybody have any questions or comments for what has been said up here for the past long time? Or are you all falling asleep? No, we have a person down here. Thank you.
Hi, Leo Bicknell, wearing at the moment my hat as one of many ARIN AC members. Since we have a panel that appears to have some experience rolling out IPv6, I'm curious if any of the panel members participate in the policy process in ARIN or your respective RIR, since I believe there's at least one person from Europe on the panel. Because the RIRs are making policy about how IPv6 addresses are to be handed out, and it's going to shape how your routing table looks in the future. And right now there is a distinct lack of folks who have IPv6 experience participating in that project. And so if you're an early adopter and you have that experience, are you participating? Are you sharing it in that forum? And if not, what can we do to encourage you to go there and share your experiences in that forum?
It's hard enough dealing with vendors.
The only point I'll make to that is, and those of you that follow PPML might have seen the thread that I started, because it's about 2 weeks ago now, about how there's lack of parity between the V4 and V6 assignment and allocation policies. That might sound trivial, but if we're all up here saying, hey, we need IPv6, we have to do this, then someone, and I'm sure that some of us are glad to help, needs to go through the IPv4 policy with a fine-tooth comb and look for spots where parity is missing between V4 and V6. In my specific instance, we were missing the multiple discrete network or site networks allocation policy, which has been in V4 for a long, long time. The fact that that's missing from V6 is a huge, huge hole, and it meant that without jumping through hoops, me as an enterprise and as a content provider could only get a single /48, which means I can only address one site. I don't have a nationwide backbone. I have multiple discrete networks across multiple sites that are interconnected, but if they get cut off from each other, that means that any addressing or any site is generally becomes an island, even though it may have local connectivity. So not good.
I've got one about Europe as well, if that's all right, if you finish. In Europe as well, the RIR address policy process is very busy. We've only actually just got V6PI passed as something you can actually order, but in case you weren't aware, and it does affect maybe some of your European business units, you can now go and get V6PI unless you're an LIR, and that's something that I'm trying to fix. I've got a policy out there at the minute, so if you're in Europe and it affects you that you can't get PI because you're an LIR, come and talk to me and I'll tell you how to lend support to my fix. So yes, I think is the answer to your question. I think the people on the panel are very engaged. Thank you, Lee.
So from a Comcast point of view, I'm sure, Leo, you know Dan Alexander. So, I mean, we generally kind of coordinate and orchestrate that sort of stuff through Dan. So I'll confer with him and see if there's something additional that we could do to support those initiatives. But you know, from our point of view, I'm kind of assuming that we're covered there. But you know, perhaps afterwards you can elaborate on you know, what do you think some of the issues are? Maybe not here, but yeah, if it's social or what have you.
Yeah, hi, I'm Mike Sinatra from UC Berkeley. I just have two comments. The presentations were all very good and very interesting. The one thing that I've really struggled with lately is on our wireless network, which does not currently support IPv6 because our captive portal doesn't yet support it. We have a problem with people doing connection sharing and sending out RAs to everyone else on the net, which Vista and Mac OS will pick up and assign themselves addresses which are in the 6 to 4 range. And they will try to use those addresses when contacting services that have Quad A records. So as soon as that particular laptop that had the connection sharing turned on gets shut down and goes away, you still have that address and you still have that route and you try to use it. All of a sudden, there is a really small island of connectivity. In fact, a whole bunch of really small islands of connectivity out there. And that's a really big problem for us. We need switches that can do port ACLs that can filter RAs, and we need access points that can filter RAs for that reason. And then one other quick comment that Randy's talk reminded me of. I think a lot of people talk about what consumers and what customers want, and do they care about whether they have IPv4 and v6, and we know that they pretty much don't. Do they care about whether they have carrier-grade NAT? But I think that in terms of costs, I just can't imagine that it could be cheaper to have carrier-grade NAT, to have your help desk at an ISP at a large broadband provider trying to deal with carrier-grade NAT problems. You know, customer reports the internet isn't working, and you've got this whole help desk hierarchy that you've got to go through layers of support. That's going to be a lot harder than dealing with end-to-end IPv6. So that's just an observation. I don't know how the big broadband providers think about that or not.
But at the same time, the pressure of end-to-end IPv6 is not necessarily on, you know, in Comcast example, on Comcast. It's on the providers of content upstream from Comcast. If it was up to Comcast, I'm sure that everyone would be IPv6. They don't want to do CGN. You know, Elaine Duran did a presentation that basically said, we don't want to do this, but we probably will have to do this. And I think that pretty much sums it up.
Hi, Michael. Nice to see you. Two things. On the first one, it's not just the switch protection, et cetera, but talk to that blonde gentleman over there from the transport area of the internet area of the ITF, who might be able to help you deal with rogue RAs at a technology level. That's a design feature that causes a lot of problems. The large broadband providers who are talking 10 layers of NAT and CGNs, et cetera, have a real problem they're trying to address. But what's interesting about that support cost is they're going to outsource a significant part of that support cost to my support people.
Hi, Dave Crocker, Brandenburg Internet Networking. I'd like to underscore and possibly expand on a point made earlier in the panel and ask a question about a point made or a suggestion made at the end. The point at the beginning was about SMTP and IPv6. We have the only reason email survives today is because of a fairly complex, diffuse, poorly understood series of lists that all rely on IPv4 addresses and which have no equivalents in IPv6 space. The elaboration might be an opportunity to think about switching to domain names as a basis for identification, but that's new work. The question is, I really like the idea of creating public incentives by the external offering of service. I don't understand what the incentives are. You can offer it, but what's going to get anybody to take it?
Gary, do you know the RSC? It's, you know Jim's old RSC.
So you know, the only comment I could kind of make to that is the subscriber base today in the residential space. I mean, what percentage do we really think understand what of them are understand really what's happening underneath NV4 land, right? So I don't know about you, but I'm not really outside of you guys, right? In this population, in this crowd, this community, there's only you know a couple digit percentage of the population that's going to call up Comcast and ask for IPv6. Everybody else probably doesn't really know what IPv6 means and probably never care, right? I think the idea there is for us to kind of, you know, devise a way to enable it gradually, and the key there is that they should never know that it's been enabled, right? Now I'm not kind of getting to. I don't want to kind of get into a place where we're talking about the economics of how we do that, or, you know, the business side of it. But you know, if you sit here and wait for somebody to ask for it, we're gonna be waiting a long time, right? That's my guess. So, you know, at least some of what conversations I've had is, you know, finding a way to enable it seamlessly, you know, kind of in a very non-disruptive fashion, so that we can kind of push the rock, right? I mean, I have a hard time believing that the phones are going to start ringing off the hook one day and people are kicking the doors down for IPv6. You know, I'd much rather see us be proactive about it as a community, you know, make it available to people in a seamless manner, so that we're kind of maturing, you know, V6.
Hi, Chris Woodfield, Internet. I was halfway out of my chair when you mentioned RIR policies, and then you mentioned multiple discrete networks, and I went to sit back down again. But then I realized that not only is that particular policy an issue, but it's the fact that there's direct conflicts between RIR policy and certain ISPs' routing policies. You know, I'll talk about my big pain point right now. I have 15 AS numbers in the U.S. Aaron will only give me 132, but there are carriers. So, you know, fine, I can take that 32, split it up into you know 36s, 37s, whatever. But there are carriers that will not listen to any prefixes smaller than a /32 at their edges.
So you really mean carrier, right? We can be more specific, right?
Carrier.
We don't have to say what carrier, but we can say carrier, right?
Yes.
So
carrier.
that goes back to the Swiss cheese analogy from earlier, right? Which, correction needed, that was actually Patrick's quote and not Barrett's quote. The IPv6 internet as a whole right now is the holes, not the cheese, and policies like that are problematic, but how do you correct that at the RIR level, especially when we specifically say that they're not supposed to be setting routing policy, which is a direct contradiction of the question they ask when you apply for a /32, which is, are you going to be advertising this as an aggregate /32? And if you answer no to that question, your application gets rejected.
Yes.
But they don't set routing policy. So I'm actually kind of surprised you've got that issue where, especially in internet, you do have multiple discrete networks. That's your business.
Yes.
So you really need that policy.
Yeah.
But that policy is going to then assume that, and just so everyone knows, that's going to be up for vote in Dearborn in October, and then it probably will pass and then be implemented by January.
Yeah. And I have requested 15/32s from Aaron,
yep.
which got rejected out of hand.
Yeah. Well, actually, in theory, you should be entitled to a 32 per AS, because each AS is probably tied to a different org ID. But that's neither here nor there. But I would hope that carrier realizes that if there's a policy that says that a site gets a 48 and that site is a multi-home site, that they would start accepting 48s.
When that carrier's customers are complaining that they can't reach something, when other people are complaining that they can't reach it, because there's money behind it, this will get solved. Okay? The problem is we're in a dip. It's just, for a while, there's not enough pressure behind, but we're trying to roll it. As we roll it, we'll finally hit the point that there will be enough pressure behind. These things will get ironed out. Just business.
Joe Myman, CHL. I just wanted to talk about a few points related to your speech, Randy. You talked about experience and how just like you had IPv4 experience, you're also going to need IPv6 experience. Well, IPv4 experience is that you don't want to repeat the same kind of pain learning curve with IPv6 as you had in IPv4, which means you want to try to hold back and make sure you're doing it kind of right the first time around. There's a disincentive there, the lack of experience. You don't want to run into the same dead ends you did back in IPv4. The other point I had with regards to NatPT, if your goal is to get V6 users to see V4 sites, isn't it simpler to simply give them RFC 1918 dual stack with NAT? And with regard to carrier grade NAT,
Can we do this one at a time? Because I'm getting old and don't have good memory.
all right.
Roll back the first one, which was,
With regards to experience,
you want to do it right the first time. How do you know what's right unless you have, how do you know what's right unless you have some experience, have tested, have played with the stuff, et cetera? Right doesn't fall from the sky.
true, but telling people that you're going to have to run into the same dead ends as you
No,
did.
it's new and different dead ends. That's what's fun. Right?
Some
And
people.
so, that's why we come here, okay, is to learn from our brothers and sisters so we don't run into those dead ends. That's why this room has 4 times as many people as the security meeting does, and 2 years ago it was the reverse.
Then
Yeah.
we should wait for some more meetings.
The second one was NatPT. That's actually my problem. IIJ is, serves the enterprise customer. A couple of years from now, the enterprise customer is going to be having tough time getting V4 space. They want to move to V6. They don't want to live in a double-natted world because they know the consequences of it, and it's much easier to get, although it's not NatPT, because NatPT was bidirectional, and what we really care about is a V6 network able to reach a V4 network. In the long run, we're going to care about the opposite, the people who haven't converted, wanting to reach the majority of the V6 network. But right now, it's 6 to 4. Pardon me, 6 to 4 is bad. NAT 6.4.
Right. And the last point I wanted to make is that today you've been very consistent in talking about carrier grade NAT as the evil that it most likely is, but there is an incentive for providers to view carrier grade NAT as a way to monetize IPv4 global addressing, where to date it isn't. You get one. It's the same as any others. But if you go into NAT, then you get to say you have to pay more for your unique address, and some people might want that.
A year ago, I stood up, not in this meeting, but ITF plenary, and said ITF NAT is evil. And friends said, yeah, that's nice, but what else those poor bastards do? And so we went home, and there's one of the poor bastards now, and said, what the heck's Allah supposed to do? And what we said was, the problem is that the customer, my customer reaching Allah's customer, sorry for picking on you, Allah, but you're used to it and we're old friends, is that new protocols, it's all the problems with NATs and double NATs, et cetera. And so we came up with some little secret sauce called A+P, which essentially moves the mapping, same mapping. You're out of addresses, you can steal from port numbers. That's what NATs do, but make it, move it, make it so that the customer can do it, so that the customer can buy a device that they can control and push straight through and therefore stick on any ALGs for Skype version 9.5 or whatever. The big broadband providers have a problem. We're running out of V4. They see it coming first because it's a big express train and they eat V4 addresses for breakfast, lunch, and dinner.
Thank you.
Thank you.
Hi, Alain Jean, Comcast. I would like to make an answer to the previous question about are we going to make money with carrier grade NAT? And the answer is I'm laughing because we are going to spend a lot of money to build this. The fact that we have a lot of V4 customers that have a bunch of devices that are only V4, don't know anything about V6, we want to go to the internet where the content is on V4, not on V6 yet. means that we would have no choice but to have some kind of a way to share IPv4 addresses when we will have not enough v4 addresses. And you like it or not, that's the reality. The thing is, none of us is going to make any money on this. This is going to be a fairly expensive proposition. We will have to buy a bunch of equipment, maintain it, debug it, and this is going to be a center of cost. This is not going to be a money generator. So we're trying to find systems to make this as low cost as possible, but we are certainly not going to make any money out of it. And what I usually say is that we like to go to v6 because a byte that moves over v6 is a byte that doesn't move over v4 and the carrier grade NAT. So that will help us to put a cap on the cost of this awful infrastructure.
There's also an interesting sector of our own industry that we haven't really touched on in this question. Access customers can stack people behind layers and layers of NAT and it'll be really bad, full stop. But what are people who host servers going to do? If your product is a hosting company, you can't deploy servers on RFC 1918 address spaces behind 2 or 3 layers of NAT. What on earth are those guys going to do? Anyone? Quite.
Igor with Yahoo, and I want to make 2 comments. That single provider who will not accept /48s. Could you? That single provider that won't accept anything better than /48s. Give it about a year. When a bunch of SMBs who currently have /24s from them, who are doing multi-homing, who constitute the majority of their business, and they buy T1s and bonded T1s, start saying, hey, I have a 48, I expect you to globally route it, or I switch providers, they're not going to be able to hold out for very long. Unfortunately, the content providers or the major ISPs, we can't quite put as much pressure on that person because we don't tend to buy from them. But it's the SMBs that do, and they can't get 32s. And the other comment on operational experience and not making the same mistakes, try asking your vendor whether they recommend /64s, 112s, or 126s, or 127s on point-to-point interfaces, and just watch the scramble inside those orgs, because they have no clue. They're saying, hey, why don't you try it and tell us? So I think we're going to have a whole new learning curve of experimentation and things breaking.
I think we could make an entire hour discussion or entire day's discussion out of that specific argument.
Yeah, but it would be nice if the people who make the gear, who know how it's designed, will actually tell us which will break worse, and they still can't.
Leo Bicknell, wearing an ISC hat this time. One thing I'd like to point out, because we have been directly affected by this, is I believe at this point all of the RIRs are making allocations, at least for some purposes, that are not 32s or 48s. In our particular case, we have a /47 as a micro allocation for critical infrastructure for a root server. And we are not the only one. Aaron has a list of them. They have 44s and 45s and all sorts of other sizes. And one of the things we've found is due to the way IPv6 was initially rolled out, it was thought that there would only be certain sizes. And a lot of people very early on wrote up, best practices filtering documents and all these other things that people post on the web of cut and paste this ACL into your router and you'll be a very happy camper. And quite frankly, the addressing process has moved forward much faster than those folks have kept up. So I urge everyone in this room caution if you are rolling out v6 services and you go find a document with, here's the filter you should put on your router, double check that that's up to date. If it's dated a year ago, it's probably wrong at this point. It's a fast-moving policy area. We find a lot of people filtering out a root server that they really want to get to because they didn't get the memo that it's not all 48s. There's 47s out there too. So that's just an area of caution.
There aren't enough v6 announcements to worry you. Don't filter by length. There aren't very many v6 announcements out there. Filter on 48, filter on 56, but don't do less. It just makes no sense, and you're not protecting yourself against a real problem. You can change those filters in the future when that happens. And in v4, this went through the same cycle. right? Unfiltered. Sean's routers were falling over. Everybody kind of said, oh, okay, we better start filtering on 19 and our IR allocation boundaries, et cetera. And that held back for a while. And then as routers became more capable, we loosened up more. And this is not a constant fixed thing, and right now there is no useful cause for filtering on a short prefix.
Nope, I would agree, but certainly if you're going to go that route, at least make it match RIR practices, please.
Okay, and I think we have last question because we have that beer and gear stuff that's got to start soon. So,
Mike Joseph, Google. To answer the earlier comment about content providers running out of address space, simply that's not the problem. Content providers have enough address space. Existing content providers have enough address space. New content providers would have an entry barrier, but it's not that great because they don't need that many addresses relative to access networks. In theory, content providers today could sit and wait, and if carrier-grade NAT was not so scary, that would work. The real problem is the access providers are running out of address space, and we need to help them. So to Comcast's question, that's why Igor is working on rolling out V6. That's why we've rolled out V6. It's because we want to facilitate the users to get to us directly without going through carrier-grade NAT. So I don't think that address depletion is our biggest concern. Our biggest concern is end-to-end connectivity and keeping out middle devices with carrier-grade.
Did my presentation give you the impression that I felt that I was concerned about address depletion versus driving adoption, or
no? Just a minute ago.
Yeah.
Okay.
I've got a. If I can reply, I think that when I've worked for organisations that are themselves large content networks who manage their own address allocations or assignments, they do have enough addresses, but these dense hosting firms. When I say density of number of servers, they're burning through a lot of addresses if they're growing and successful. So I work with a number of hosting companies who are burning through a /19 every few months, not because they're being wasteful, because they're being good at what they do, and people are flocking to them and hosting with them. And these people aren't being wasteful with addresses, and maybe one address per server, and that's that, but they're still burning through addresses because they have to number each device uniquely. And those guys have got a problem if V4 depletes and we haven't got something better, because those guys have a genuine need for one device, one address, and they're going to run out soon.
okay. Right. Thank you. And thank you to the panelists. Those were really good and exciting. And thank you for the comments.